All right, ninth graders, today we're going to work on doing some calculations on potential and kinetic energy. And I've put the two equations right here. For potential energy, it's mass times gravity times height. I'll just write it like this. I want you to notice something, that the first two letters here, mass times gravity or gravitational acceleration, are the same thing as weight. So we can actually write this equation as PE equals our weight times height, F sub g. So if you're doing a problem and it gives you the weight, then use this equation. All right, and then our other equation, 1/2 mv squared for kinetic energy. So I'm going to go through this and just do 5 of the problems, and then you're going to do the rest. So first question, calculate the potential energy of a rock with a mass of 5 kilograms while sitting on a cliff that is 30 meters high. So it says calculate the potential energy, so that's what we're looking for, PE, and we have a mass, M, of 5 kilograms, and it's sitting on a cliff that is 30 meters high. All right, now our equation for PE is PE equals mgh. And we've got m and we've got h, but we don't have g. However, because we're here on Earth, we always know what g is. G is 9.8 meters per second per second. And from this point on, I can just plug my numbers in. I go 5 kilograms times 9.8 times 30 meters. All right, and then I grab my calculator. And that's going to be 5 times 9.8 times 30. And that's 1,470 joules. All right, let's move on to number 3. Okay, number 3 says calculate the potential energy of a 450 Newton washing machine sitting on a warehouse shelf that's 2 meters above the ground. All right, so again, we are going to calculate. This was number 1, this is number 3. Again, we are going to calculate potential energy. And what are we given in this problem? In this problem, we are given that the washing machine is 450 newtons. Well, remember, newtons measure force, so that's actually my weight, 450 newtons. And it's sitting 2 meters above the ground, so that's my height. And the equation here is PE equals weight times height. So that's going to be 450 newtons times 2 meters. And I won't get the calculator up for this, but it's 450 times 2, that's 900 joules. One thing I would point out on problems like this, the most common mistake that people make is they see that 450 newtons and then they multiply that by 9.8. But remember, F sub g, the weight here, is already been multiplied, m times g, mass times gravity, to get that in the first place. So we don't multiply our weight times 9.8. Number 5, what distance is a book from the floor if the book contains 195 joules of potential energy and has a mass of 5 kilograms? So here, the distance the book is from the floor is the height. We're trying to find height. And it contains 195 joules of potential energy, and it has a mass of 5 kilograms. All right, and so how do we do that? Well, again, our equation is this, PE equals m times g times h. Well, if I want h will equal PE over m times g. So this is going to be PE, This is h equals PE over m times g. And again, g is not given in the problem, but it's 9.8 meters per second per second. All right, so now I just have to plug the numbers in, 195 joules over 5 kilograms times 9.8 meters per second per second. All right, so again, I get my calculator out here. and that's going to be 195, oops, that's going to be 195 divided by, in parentheses, 5 times 9.8. And that equals 3.98 meters. All right, so that was number 5. Next, we're going to do number 8. Okay, number 8. Number 8 says that a car is sitting on a hill which is 20 meters higher than ground level. Find the mass of the car if it contains 362,600 joules of potential energy. So again, let's start out by writing down the things that we are given. We know that the height of the hill is 20. And we know that the amount of potential energy is 362,600 joules. And we also know that G is 9.8. And we are asked to find the mass. All right, so let's take a look at what our equation is here. And we're trying to find M. So M equals PE over GH. All right, so then I can plug my numbers in. So 362,600 joules over 20 meters, or 9.8, sorry, times 20 meters. Again, I'm going to put that in parentheses so that my calculator gets it. And let's get the calculator out here. I get 1,850 joules. All right, that's number 8. And finally, I'm going to do number 12. Number 12 is a kinetic energy problem. Number 12 says calculate the kinetic energy of a truck that has a mass of 2,900 kilograms and is moving at 55 meters per second. So we want to find KE, and we're given that the mass is 2,900 kilograms, and we know that it's moving at 55 meters per second, which, by the way, is crazy fast. That's like 120 miles an hour. All right, so to find kinetic energy, we look at our equation, 1/2 mv squared, and KE is what we're trying to find, so it's just these three things multiplied by one another, and that's going to be KE equals 1/2 mv squared. I'll plug my numbers in. 1/2 times 2,900 times 55, and I square the 55, right, just like I showed you in the notes yesterday. And to do this one, then I go 1/2. 1/2 is the same as 0.5, so I just type 0.5 in, times the mass, 2,900, times 55 squared. I hit the squared button right here. And only the 55 gets squared, remember. I hit equals, and that is a rather large number, 4,386,250 joules. Okay, so that is it for the potential energy and kinetic energy calculations.